Hello everyone, my name is Sedat. I am from Hisar Idea Lab Fab Lab in Istanbul, Turkey. Uh, since last May, we have been working on Parametrics. It's a web platform that helps students learn parametric design easily. Learning parametric design can be hard, And by the way, my background, I'm the Fab Lab instructor and Fab Academy instructor, and I am the computer science teacher. And I know how to teach about the parametric design for the students. And we tried learning parametric design can be simple and fun. And now my students Emre will explain how parametrics works and how it can be used in education. Emre.
Thank you. So just as Mr. Sadat mentioned, we come from Istanbul, Turkey, from the Ideal Lab Fab Lab. We have been a Fab Lab for about 6 years, and we have been a Fab Academy node for about 1 year. And our general research has been based on human-computer interaction in the past. So what is parametric designing? Parametric designing is basically a transformative approach in CAD, where the geometry of the design adapts on the changes made by user parameters. So the user defines parameters in some kind of interface in their CAD program in order to adjust them after their design. It's a useful technique because it makes editing and post-production of the design much easier. So let's talk a bit about the origins. We created Parametrix mainly to teach parametric designing in digital fabrication laboratories to students in Fab Labs, mainly our Fab Lab. Since in parametric designing, there are a limited amount of beginner resources, as the student tries to progress further in CAD by learning this technique, they struggled to interpret and understand the fundamentals. So with Parametrix, we aim to reduce the steep learning curve generally associated with this technique. So just to give an overview of our web app, the web app mainly consists of two sections. The tutorial interface, which is basically where we provide the first knowledge to the digital fabrication students when they come in, with tutorials ranging from a simple cube to a simple space rocket, providing them a framework to create multiple shapes and multiple different designs in Parametrics. And the playground interface is basically where students may decide to go after they have completed the tutorial interfaces. It's basically a space for experimenting and trying out new designs, doing quick prototype, etc. So the main point of the tutorial section are the tutorial booklets. The tutorial booklets basically are for giving the knowledge students require in parametric designing, and they're not a medium which are monotonous. Firstly, they prompt the student to think about what to do in the next step, how to design it, how to create the certain prompt there, and then the knowledge is given to them. So we create basically a system where firstly the student has to think themselves and ideate over it, creating a better and more engaging learning process. And as I talked about it, mainly Parametrics works basically with prompting. Shapes are created with prompts in Parametrics. So to make this prompting system work, we fine-tuned an NLP, specifically the large language model, specifically the Google Flan T5 model, in order for it to be able to parse and understand basic properties of the shape. The JSON structures of the parsed prompts mainly consist of 4 sections. The shape type, the parameters dependent on the shape. If it's a circle, for example, it's the radius. If it's a rectangle, it is the width and the height. And if it's the cone, it is the height and the radius. The construction plane, like traditional CAD software, 3 constructions planes are there. There are the XY, XZ, and the YZ construction planes. And the coordinates, the center coordinates of the shape. By using these prompts, the student may create any shape they desire. For example, if they say, create a circle with a radius of 5, on the XY construction plane, a circle looking right at them will be created. As I talked about the model, it is basically a large language model assigned to the Flan T5 LLM. So yeah, to talk in a more broad sense of the tutorial interface and its general structure, tutorial interface consists of 9 distinct tutorials. And it starts out quite simple, just teaching the fundamentals of parametric designing and how parametrics works, in the sense that how to prompt the model, how to get into the framework of parametrics and the structure of the prompts and how it works. is basically taught in the first story, while as they progress, they'll see further things. For example, how to design shapes parametrically, how to make shapes before so that they match with the other parameters, how to adjust the parameters in post-production, etc. in the Parametrics framework. And then there's a playground interface. As I mentioned, it is basically quite similar in structure to the Parametrics interface, but it's missing the instructions. It is basically a space where students can freely implement and test out anything they want. It is after, like, it's a set space between the learning phase, which is the tutorials, and a professional, more advanced CAD software, which requires more editing and more knowledge in CAD. It is basically a space for the students to try out the techniques they learned without any guidelines, to experiment, to see what they could do with the new techniques they learned in Parametrics, how to design simple shapes parametrically. For example, they may design a simple case for a Raspberry Pi in here or other stuff for their own progress after the tutorial booklets guidelines. And additionally, we added a feature which allows the students to make their designs materialized. Mainly, there are three ways for any person to materialize their designs. They may export their designs as a DXF file, then to either edit it further in a environment, adjust the sketch, or to print it out from a designated machine which takes the DXF file, such as a laser cutter. They may export their shapes as an STL file to send it to their printer slicer and print it out. And also, we have direct communication feature with the 3D printer. It currently only works for the Bambu P1S series because we had to write an API to customly access it, and the only printer which provided the properties needed to directly send G-code to it was the Bambu P1S series, and so it only works for that. But basically, when the student, after completing a design, if they have this printer, they may just enter their identifying credentials of the printer, like the serial number, the IP address, and etc., and they may send their files, they may send their STL designs as a G-code to print it out there. And to talk a bit about the ecosystem of Parametrics, basically, when a student enters Parametrics, it will have to go through these steps to create a simple design. At the start, the student will first have to obviously enter and select a tutorial to learn something. And after that, in the tutorial interface, they will have to go through the instructions in order to create the design they want to create. After that, the student must type the designated prompts there, which are given in the booklet, as I mentioned previously, to create their designs. But this will only create a 2D interface for them. To export them to 3D and adjust it, they must go on to the JSON editor and extrude them from there. Parametrics has a proprietary JSON editor, which is basically for adjusting the parameters in post-production, etc. And they use the extrusion feature here to make their design into 3D form. After that, they can extrude their design as an STL and send it to their designated slicer. As I mentioned, in our lab, most of our printers are Bambu Lab printers, so I just explained it here of Bambu Lab. They may put it in the slicer and then send it to their designated printer to print it out. And here is a logic diagram for that as well, if you want to take a look at it. So basically, when building parametrics, we use multiple different programming languages for multiple different tasks. If you could give me a second, I'm just going to share with you the UML chart we have. So basically, for the front-end design for the app and the interfaces, we used React.js because it was the most convenient one for us because we had to create multiple dynamic interfaces, and the component structure of React was most feasible for us. And after that, for most tasks, except for the AI-based tasks, for example, for the file exportations, for communicating with 3D printer, we decided to use Julia because we needed speed in those. We needed extreme speed in those tasks, and Python didn't just give the necessary runtime speeds we needed. And for the AI model, since most native libraries were on Python, we decided to use that. As you can see, here's a sample structure code. Basically, when the student enters the app, they may choose either to go to the playground interface to then navigate toward creating a design, to either export it as an STL or DXF, or use the Bambu Lab printer API. We custom designed to send it directly to their printer. Also, to prompt the model, we created a simple REST API with Flask and in Julia for the tasks to communicate with the React frontend. Just want to talk about finally how parametrics may be integrated into learning environments. So as I mentioned, Parametric serves as an ideal introduction platform for a student. It does not aim to be a medium which replaces traditional CAD software such as AutoCAD, SolidWorks, or Fusion360, but it merely aims to be an introductory material to introduce kids to the concept which they're unfamiliar with, because parametric designing requires a lot of hours in the current resources. Since they are quite hard to understand, we created this platform as a middleman between the traditional computer-aided design techniques such as direct manipulation and parametric designing, doing parametric designing in traditional CAD software as a learning tool. It may be most ideal in a step between, as I mentioned, the CAD softwares when the student knows some CAD but is unfamiliar with the new program, and it provides the new technique, and it provides basically a space for trial and error in learning and hands-on experimentation. And thank you for listening. You can contact us at this email, and if it'd be great if you could fill out the survey. And if you want to check out the code, you can look at the GitHub repository. Does anybody have any questions?
Hello, can you hear me?
Yeah, I can hear you.
Okay. If the project that you made is really, really amazing.
Thank you very much.
Yeah. I am also a FAB Academy instructor here in Paraguay, and we started to teaching parametric design with Grasshopper. And the interesting thing is the graphical programming. So my follow question is, this project have the possibility to add a graphical programming instead of prompting? Because I found that most students that is not related to the programming or to coding, they have a fear in front of the prompting. So it facilitates the graphical programming in order to get the 3D model and stuff.
Mhm.
So that's my question.
I couldn't quite get the last part of the question. Could you repeat that because of the background noise, please?
I'm sorry. My question is if you can add graphical programming instead of prompting.
That was actually a next step we thought of adding into parametrics, but in the fundamentals, we just wanted to lay out a framework to do it simply. But after that, in the next steps for more advanced computing, after the main framework was done, we thought of adding that as well. Thank you for your question. Are there any other questions?
Is there a publicly available hosted version of this we can play around with, or is it just download the code and run it yourself?
It is not publicly available yet, but in the coming months, probably in the next month, we will try to upload it into the cloud. After it is complete, then we are just doing the fine-tuning and stuff for the last production currently. But in the coming months, it will be available publicly.
Cool.
Yeah, we think this project's ready in the middle of the March. And we tried now, and we need especially like you some experience feedback.
Yeah, if you want to download it, we can send you any file if that's missing, but we have everything there, the package.json for downloading proprietary models and everything on there. If you want to try it, that would be obviously great.